Alright, so now that we got the audio fixed, today is the 8th of September. It is a nice Friday, nice weather outside. We're going to do a warm-up based on yesterday's notes. Okay, so if you remember from your notes yesterday, looking at number 1 on here, we have a 90-degree angle. So what do I call two angles that add up to 90? Okay, complementary, not a right angle. There are two that add up to 90. That's complementary. Like Miss Marrero told us, giving compliments is the right thing to do. Complementary. So, complementary. And also, since they're next to each other, we call that adjacent. So, how do I figure out x? Okay, I know 54 plus x equals 90, so if I subtract it from 90, I'll get my answer, which is 36 degrees. Okay, 90 minus 54, that's the complement I was looking for, meaning the complement of 54. Now, number 2, what kind of angles are these if they make a straight line? Well, they make 180. Straight line, what's another phrase we learned yesterday? Linear pair. Now, they are a linear pair. What else would we call these if they add up to 180? What else do we call them if they're a linear pair and they add up to 180? Supplementary. That's what's up. So, supplementary. And since there are two angles touching, we also call them adjacent. So, how do I figure out angle x here? Subtract from 180. Okay, so 180 minus 31 is 149 degrees. Okay. And last but not least, number 3, what kind of angles are opposite like that? Okay, they're called actually vertical angles. So remember, vertical does not mean they're always up and down. It just means they're opposite or across from each other. So these are opposite or across from each other at an intersection. So we call these vertical angles. So, what do we know about vertical angles? Okay, everyone else, you should have your vocab from yesterday. Vertical angles are congruent. They're equal in their measurement. So if this one's 35, what's the vertical angle going to be? 35 degrees. Because vertical angles that are opposite from each other at an intersection are congruent. Okay? So you'll notice this says notes. These are notes. Even when it says practice, that's practice on the notes. So again, notice we're doing notes. There's a reason why the first section is 6 algebra-based problems. If you look at the left side where it says simplify, what do you think of when you think of the word simplify? Okay, you make it condensed or smaller. So that's what we're going to do. There's no equal sign. We're not getting rid of anything. We're just combining like terms. So, what are my like terms? 4x and 2x. Add them up, we get 6x. 3 and minus 1 gives me 2, right? And it's positive, so plus 2. That's it. When you simplify, you're not giving me one single answer. You're giving me an expression that is simplified. So on the one below it, what do I combine? Negative 2x plus 4x. What's that? Positive 2x. Okay. Now I'm going to bring down this positive 4 after it, because usually we have our x term first and our constant term second. Again, that expression is a simplified version of that original problem. Okay. So anytime you're simplifying, you're taking multiple things, making it more simple first. Then the middle segment is the next thing you might need to do. Set it equal. So we've been doing this on the warm-ups. Can we get x on one side by itself? Yeah. Right? So let's do that. When x is on both sides, what do we do first? Okay. We've been getting rid of the smaller x, and the smaller x this time is a positive 2x. So we're going to subtract 2x. Subtract 2x. Okay, these cancel out. What is 3x minus 2x? 1x. You can also just put x. Bring down plus 1. And this is kind of weird. What is 2x minus 2x? 0x or just 0. And that's okay to write. Don't leave it blank because what is that? Okay, put a 0. Now, if 0 makes you uncomfortable, we'll fix that. Last step, get rid of that positive 1. What do I do? Subtraction. Minus 1, minus 1. X equals, and 0 minus 1 is negative 1. Okay. Below it is another example, more solving for x stuff. X is on both sides. What do we do when x is on both sides? We don't always subtract, but we do get rid of the smaller x, whatever it is. So what's the smallest x? Okay, now that's kind of weird. That's new, right? Decimals, but it's okay. 1.5x has got to go, so we're going to, in this case, subtract 1.5x minus 1.5x. What is 2 minus 1.5x? 2x minus 1.5x. 0.5x, that's a decimal for a coefficient. That's all right. Let's bring down minus 3, equal sign 1. Now this looks like the two-step problems we've been doing, except there's a decimal, but that's okay. What number do I need to get rid of first? Here. The minus 3, how do I get rid of a minus 3? Positive, plus 3 on both sides. What is 1 plus 3? 4. Bring down equals, bring down 0.5x. And then how do I get rid of the coefficient? Anytime I need to get rid of a coefficient, how do I get rid of it? Divide, okay? If it was a whole number 5, we would divide. If it's a decimal 0.5, we're still going to divide. So let's divide by 0.5. Yes, you can divide by a decimal. Use your calculator. So 4 divided by 0.5 gives me 8. Okay? And on the right column, we'll do one of them together. And I think at that point, you'll get the point. Okay? But top right, if I have more than one x on the same side, just like the first column, I'm going to combine like terms. First, we got to simplify. So 2x plus 4x, 6x, negative 1 plus 7, plus 6, equals 180. Okay? And now I must keep going. It's a two-step problem. I'm going to get rid of that loner, plus 6, by doing the opposite. I'm going to subtract 6. What is 180 minus 6? 174. And our last step is we divide by 6 to get rid of the coefficient, and we should get 29, I believe. Okay. The last one I'll show real quick. This might be kind of fast, but it's because we've been doing the stuff. We know how to do this. We first combine like terms. We bring down everything else. We get rid of the loner. And then we divide by the coefficient. So you should get x equals 13 on that last one. Okay? Again, a little fast. However, we've been doing this. So it's kind of more checking your work on that one. Let's take the algebra we've been studying and let's talk about the name of this whole notes sheet, angle and segment addition. Now let me simplify angle and segment addition into one phrase. And it might be kind of intuitive. It might be kind of obvious. Okay? Go ahead and write this. In general, if you have parts, one part plus another part, however many parts there are, if you add them up, they're going to equal the whole. So let's say there's two parts of a segment. Add up the two parts, they're going to equal the whole. Let's say you got an angle, and it's broken into two parts. The two parts will add up to equal the whole. So on number 1, we have R between F and Y. So go ahead and draw yourself a segment with F and Y at the end, and it says to put an R between them. Okay? What you need to do is label it. It gives us what we need to label. Does everyone see? It says FR, for real, equals 3x minus 2. Let's label FR as 3x minus 2. And then it says RY equals 4x plus 7. So let's label RY 4x plus 7. So those are the two parts. If I added those up, they're supposed to equal the whole. Does it tell us the whole FY? If we keep reading, FY equals 96. So FY equals 96. So, like I wrote up there in blue above, number 1, the part plus the part has to equal the whole. So what I'm going to do is I'm going to rewrite these terms as an equation off to the right. Do it in blue here. So my first part on the left, FR, plus my other segment, RY, has to equal the total FY. So I replace each of these segments with their measurement. FR is 3x minus 2. RY is 4x plus 7. And FY is 96. Are there questions on why I set it up that way? Left part plus right part equals whole part. Now we're going to solve it like we did at the top of this page. Combine like terms, 3x plus 4x. What do we get? 7x. Negative 2 plus 7. Positive 5 equals 96. And now we have a two-step problem. The loaner is positive 5, so we subtract 5. And then to get rid of the 7 in front of x, we divide by 7. X equals, if you do the math, you should get 13. Each step we've done before. Combine like terms. Get rid of the loaner. Divide. I think the new part about these problems is that I'm making you take the bare algebra and apply it to some geometry. So you got to bridge the gap there, and you have to set up your own equation. So that's what I want you to do on number 2, is set up your own equation and solve it. There's only one edit I want you to make to number 2. It should not say 10. Scratch that out. I want it to say 24. So I want you to set up number 2 and solve it. Now this is a quick rundown. Number 2, QR is 5x minus 2 plus RS is 24. That equals the whole thing, QS, which it says right here, is 15x plus 2. Okay, now if you didn't read it at the top, that's what you got to look for. It'll tell you all that you need to know, typically. Then you combine like terms, bring everything else down. Let me move this up a little bit. X is on both sides, so we get rid of the smaller x. And then our last two steps, we get rid of the loaner. Minus 2, 20 equals 10x, and then we get rid of that 10 coefficient by dividing. So again, a quick run through because we've done this before. But does everyone see that you have part in QR plus part in RS equals the total QS? You got to read the problem to figure out what QS is. Okay? Not every